Hi and welcome. This time around I have a project to help mate this rotary indexer, this Haas rotary indexer. It's electronically controlled. Mount it to a surface grinder, and I'm just making the mounting plate for it, not doing the electronics, so that would be interesting too. So we've got a couple pins on the bottom here. Let me rotate this. So we have a couple of pins here that will mate up with the plate that I'm going to be making. And there's some screws that go through these little slots here that will go into the threaded base, and then that base will connect to the T-slots on the surface grinder. And if you're wondering, yes, this is in the trunk of my car, but it was heavy enough I really didn't feel like moving it, so I just left it here because it's quite heavy. And we'll just make the plate and then bring it out and match it up and make sure it fits. So I made some drawings from the drawings they provided me. I set things up typically in a way that makes it easiest for me to machine something. So in this case, they want everything referenced off of this pair of holes up here. So I used this hole as my reference point and then measured the spacing of all these other holes relative to that. They provided a 2-inch thick slab of aluminum that's 8 by 8 inches, but the final part is 6.125 by 7.375. So we're going to saw off some of the excess material here and make it easier on ourselves. And then we'll still need to machine them all square and whatnot. Then I need to take this 1.875 down to, 2-inch down to 1.875. So we'll have to face this off on both sides, and we'll make the plate from there. Being aluminum, I was looking for references for my corners, and I noticed it had been dropped and there's some dents here. Well, that'll make the bandsaw not cut as straight as it could, so we'll fix that before we cut this. Here's another one here. So got to be careful. It's a lot like stoning your work when you're trying to do precision work. The bandsaw also won't cut straight if this isn't sitting straight on the fence. So we're just going to cut this piece down to size. I left extra to machine off. I'm using a pretty coarse saw blade and it's cutting pretty quickly. That big funk you see is where the ends of the blade were joined. I'm not quite sure why that happens on some of the blades. This was bought from a professional blade maker, so I don't know, maybe my saw does something to them because it's happened before and it seems kind of unusual. Anyways, it's cutting nice and quickly, as you can see, even though it's 2-inch stock. Next up, we have to dimension this stock, so we're going to do the outside edges first. This being 2-inch thick, I need a pretty big cutter, and so I'm looking for something large diameter so there won't be a lot of flex. Now this is a weld and holder, but not a cutter with a weld and flatten in it. But what I'm counting on here is typically what happens is the bits push up inside, and this is bottomed out, so it can't push up any further. And let's hope that actually works out. So we're first going to take the lightest cut we can take until we just get material removal across the entire length of this. Once we do that, we're going to flip it around, and then we're going to start measuring for length. The low shot spot should be on this side, so we're tightening everything up on the table, and we're hopefully going to be able to do this without too much issue, but there might be a little bit because this is a big cutter and it wants to pull. Okay, so we're just barely making contact. I'm locking the x-axis. We almost cleaned up across the whole thing, just missed this edge here by the tiniest amount. So we're going to go in another 10 thousandths. I'm going to lock the table again. We got quite a lot of material to come off here. I think I'm going to slow down the RPM so we can avoid the chatter. Get it down to like 900, see how that works out. We have a boatload of material to come off here, so I don't know how much we can do at one time. This is climb milling. And it's really removed material nicely. I will say this is making very easy to clean up swarf. To measure, I clean off the top of the vise jaw and I let this thing lie flat on the vise jaw and then walk this in. That way I know there's no hanky-panky with rocking side to side. You want to know how I know there's deflection? So I just completed a cut. If I go back the other way, theoretically, if there was no deflection, I shouldn't cut anything. But quite often, it actually removes a lot of material. Not so much this time, but definitely removing material like the 1,000th or two, it looks like, which is still quite a bit. So we have a lot of material to come off, so 125 thousandths, so we're gonna do 50 thousandths pass. So I didn't lock my knee on this, and it shifted by 1,000. Getting a better finish when don't load the cutter so much. Still not using lube. These are aluminum cutting inserts, so they're positive rake and they're polished. Then they've got a coating on them that's very shiny. And that should do it. So the drawing I got from my vendor was a little bit loose in specs. So when I measured these parts, he put them at 0.570. I measured them at 0.564, so 6 thousandths under. That's a lot of slop. I mean, maybe they want that for moving the fixture out. So because my measurements were different than the vendor's, I was going to make a test piece to make this fit because these alignment pins are pretty important. But instead, I printed a scale drawing and just cut out the holes and set it on top, and the alignment is right on. So that's perfect. That's a great advantage of having CAD with something like an inkjet or laser printer that prints to scale, because they're fairly accurate and you can check your designs like I did here. All right, right now I found my zero here in the top left-hand corner of the part. However, the important thing is the relationship between these two holes and these four holes, not the corner of the part. So what I'm going to do is I am going to go over one to find my first hole position. It's y-axis 1, there we are, and x-axis 0.75. And this is going to be my new zero for both x and y. Now everything in this part will be relative to this hole here. You can see better here. I've repositioned, or I've redimensioned all of the holes in the part now relative to this hole. And I don't care about the outside anymore. Everything's relative to these two holes so that the fixture will hold the indexer in the right spot. First step, I'm just going to center drill all of the holes. And instead of using the normal arm that comes with the mill, the drill arm, I'm using one of the quill wheels I got. Pretty fantastic. It's really great for drilling, so you don't have to constantly reorient the quill. Because on this one, it ends up never being where you need it. You know, you drilled this far, or by the time the drill bit's touching, you're already down here, and now you're going to the back, so you got to reposition. It's just much easier to use the hand wheel. All right, so first up, we're going to center drill all of the holes. Now that I've center drilled all these, I can line this up. I took a scribe pushed it down the middle of this guy. And after I get two of the holes lined up, so I've got this hole, and I'm trying to square this up here. And that one. Then I can verify the other holes. All are nice. Since I want to pre-drill all these holes with a smaller drill bit before I go for the big ones, I'm actually going to use my tap drill for these 2 3/8 holes here and here and drill every hole out here. And then I'll come back and make them bigger to their final dimension, so that way I don't have to use lots of different drill bits. Alrighty, next up, 2 1/2-inch holes, well 4 1/2-inch holes. So I missed it, but drilled these 4 holes out to 1/2 inch. These 2 need to be bored out to 0.564, and these 2 guys here need to be counterbored 1 inch down, 3/4 of an inch. So we will do that part next, and we'll do the final boring down here. All right, so next up we have a 1-inch end mill, and I have locked both the X and Y axes on the mill. I've set my 0 and on my quill DRO, and we're just going to go slowly. We're going down 3/4 of an inch. This is 450 RPMs. Hopefully this won't be too much. Oh. This might be too fast, so we're going to go to back gear. Try 170 RPM. Making pretty chips. And we're there. 2 down. All right, next we're set up with a boring head, and we're going to bore down 0.4 inches, and we're going to go out to 0.564. And I have my axes locked off, but I bumped the frickin' thing. Hopefully we're going to remove more material than this. There we are. And I'm going to stop at the bottom so I don't scratch on the way up. And make just one line there. I've readjusted the boring bar, made an initial measurement. And now we're going to go again. Much cleaner. I was not getting good clearance, so now I am. That's good. So I've got 15 thousandths to go. I'm going to drop this guy down some. I want to be able to fit this gauge pin in here. So I'm going to give myself some more space. So we're definitely not there yet. That's a 1,000th over gauge pin. I need to reset my depth 0. Alrighty, that should be on size. Ooh, oh, holy cow, is that a good fit? Oh man, look at that fit. No wiggle, it just barely goes in. That's freaking amazing right there. That's pretty awesome. Okay, let's do the next hole. And we should be good. And look at that fit. That's a beauty. I made this one slightly loose, and the other one still doesn't wiggle at all. I hope I don't need more because those pins are damaged, but we're right on the money there. I'm going to take this guy out and go test fit it. I'm also going to deburr all these edges here. I've got a 0 locator for the horizontal, and the rear jaw is, the fixed jaw is the other location. So I should be able to come right back to this if I need to. We'll see how much, if any, I need to take off. Last step, got the tapping machine over here. Got a part mounted in the vise. We just need to tap 2 holes. That's 1. Here's the final part, looking pretty. These 2 holes here line up with these 2 pins right here. Here's the pin that's oval, here's the one that's still round. Right next to are the screw holes, that's what these threaded parts are for. And these guys are 1/2-inch bolts that screw down to the surface grinder. His surface grinder has a T-slot running down the whole center. And so let's do a quick fit up of this guy. One of the bolts goes through here, and they're not both the same size after all, because this side's much thicker, so I found a more appropriate sized bolt for this side, and we're good to go. And the 2 1/2-inch bolts go up here. The countersinks are on this side because this is down towards the face of the plate on the surface grinder or the sled. And that's it. Thanks for watching. Hope you find it useful. Hope to see you next time.